Але сьогодні у нас суперфінал. Я вітаю наших суперфіналістів. Традиційно захист 5 хвилин, відповіді, запитання вже, як вийде, намагаємося триматися регламенту там 5-7 хвилин. Але якщо буде дуже багато питань, то я думаю, що надамо можливість і поставити питання членам журі, і дати відповідь суперфіналістам. Суперфіналісти захищаються у нас англійською. Питання будуть англійською, можливо, навіть українською, але відповіді суперфіналісти дають англійською мовою. Тому я ще раз всіх вітаю, як то кажуть, take it easy, тобто все спокійно, все добре. І ми розпочинаємо з нашого першого суперфіналіста Бондаренко Владислав. Будь ласка, завантажуємо презентацію і надаємо слово Владиславу. Владислав, ви тут?
Так, мене чутно, видно?
Так, так.
Можу починати?
Please start, yes.
Okay. Good afternoon, dear jury and contest participants. I'm Bондаренко Владислав Витальевич, 10th grade students of the Scientific Medical Lyceum Dnipro, and I offer for your attention a research paper on the topic research on the ecological condition of the recreational areas in the city of Dnipro. Next slide, please. The relevance of the topic is that our national surface water, rivers, lakes, seas, oceans are in serious threat, and the ever-increasing pollution of the environment. Plastic waste in natural water bodies caused by the greatest damage to the environment. It can get there, for example, during the discharge of rainwater through storm sewers, and then while being on recreational land. The same modern environmental problem as overpopulation leads to excessive water consumption. If the rate of pollution of water sources doesn't decrease soon, humanity and the animal world will begin to experience water shortages. Next. The goal is to conduct a study of the level of pollution of river water and sand from recreational areas of the city of Dnipro, and to substantiate the methods of the cleaning. To achieve the said goal, the following tasks were formed. First, to analyze the ecological consequences of a high level of pollution in recreational areas, to assess the level of contamination of various samples of the river water taken on various beaches in the territory of the city of Dnipro, to assess the quantity of sand using the gross tests, and to justify measures aimed to reducing the level of pollution of river sands and water, i.e. beaches in general. Next. The object and subject of research you can see on the slide. Next. What are lands, territories of recreational purpose? Lands of recreational purpose are recognized as those used for the organization of public recreation, tourism, and sports events. For example, beaches can also be called such lands. Next. The experimental parts of the work consisted of 3 stages. Stage 1, selection of sites and collection of samples for research. During the period from September 27 to 30, 2022, 6 samples of sands and 1 water sample were taken from different beaches of the city of Dnipro. The location of the beaches were as follows. Heroev Avenue 1, Kosa on the Heroev Avenue 3, and Monastyrsky Island. Next. Stage 2 is conducting water tests. The river water samples passed 6 different tests, namely to measure the amount of phosphates, nitrates, to measure acidity, carbonate hardness, and general hardness of water. Also, with the help of a special device turbidity meter, the turbidity of the water was measured. Next. Here you can see a graph with the results of river water tests. So from it, we can conclude which of the water samples proved to be the worst or the best in each of the concluded tests. Therefore, according to the results of the conducted research, it was established that the water collected on Monastyrsky Island is the dirtiest. The dirtiest water in terms of turbidity was the water from the beach on Kosau in the Heroev Avenue 6. Next. On this slide, you can see the samples of research stand. Next. 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 The third stage of this work was the planning and germination of indicator plants in the sand. To assess the quantity of sand, a sheet of filter paper was placed in petri dishes, and 15 to 20 grams of different sands sampled were sprinkled on top. After that, 15 to 30 seeds of indicator plants were planted, depending on their size. Then was added 5 milliliters of boiled drinking water. Also was used the thermostat to ensure the same temperature conditions, which maintained the constant temperature of 25 degrees Celsius for 3 to 5 days. Next. The first indicator plant was watercress. It was planted with 30 seeds and germinated within 4 days. Next, the second plant was the pea, which was planted in each petri dish with 15 seeds, germinated for 5 days. Next. Next. And the third plant was a radish, which was planted with 30 seeds, germinated for 3 days. Next. After the germination of each of the indicator plants in the sand samples, the heights of the shoots of the plants and the length of its roots were measured. Then the arithmetic mean error, variance, and subsequently the t-index, which was compared with the normal value of t standard, thereby determining the quality of the studied sand. So, according to the results of planted watercress, table 1, the sand collected on the beach of Monastyrsky Island performed the worst. In the sand from the beach on the Heroic Avenue 1, watercress grew the best. Next. According to the results of the planting of peas, table 2, we have that the sand collected from the beach on Kosa on the Heroic Avenue 6 turned out to be the most polluted of all, and the sand collected on the beach on the Heroic Avenue 1 was the least polluted of all. Next. In the experiments with radish planting, table 3, it turned out that the most polluted was the sand collected from the beach on the Heroic Avenue 1, and the least polluted was the sand collected on Monastyrsky Islands. Next. Please let me know, read the conclusions as they were formed during the presentation presented on slides. Next. Next. And thank you for your attention.
Thank you, Władysław. So we wait for questions.
Якщо можна, я почну. У мене буде типове питання, буду трошки інакше формулювати, але питання буде типовим до всіх учасників. Яке загальногуманітарне значення, от якщо вас спитають там в Швеції, якщо представляти Україну, яка користь від вашої роботи до планетарних, так би мовити, або загальноєвропейських масштабів? Як можна розповсюдити результати роботи на інші об'єкти?
Thanks for your question. The practical significance of the work lies in the development of measures aimed at reducing the level of pollution in recreational areas. Also, we can spread our work by some Facebook or Instagram or some television, social network at all.
Sense.
Okay, thank you. I have one more question. What are you going to do next in your project? Are you going to continue to make this research, or you plan something new?
Thanks for a question. In the future, we're planning to continue our research, of course. We want to collect different samples of sands and water from different beaches, which are on the river Dnipro, and also to compare the results of the one beach and from the other beach, and to do some conclusions. Also, as I said, we're planning to tell everyone about the problem of this work, about the international problem of pollution of rivers, lakes, seas, and surface water at all, and try to do something better for our world. and the ecology of it all.
Okay, thank you. Any questions?
Yes, I have a question. Can you please explain a little bit how can you implement the results of your research in Ukraine? What could be the nearest steps to do so?
Thanks for the question. As I said, we're planning to show everyone this problem. We can try to go on television to show our problem there, and also in some social networks to show the problem to people and try to do something better, probably to do the ecological of these beaches better, to clear it with people that will interested in this problem, and do something like that.
Thank you.
Окей, thank you, Владислав.
Thank you.
Дякуємо, Владиславу, дякуємо керівнику. Переходимо до наступного нашого суперфіналіста, це Виговська Дар'я.
Юля, можу я сказати?
Так.
I want to say for everyone, once more, please say I, not we. Understand? Everyone, do you understand this?
I think they understand.
Okay.
Виговська Дар'я. So you can start. Дар'я.
Мене чутно?
Ага. Так, все.
Dear jury members, I'm Dar'ya Vygovska, an 11th grade student of the Central Ukraine Scientific Boarding Lyceum. I would like to present to you my project autonomous installation of obtaining water from the air. Next. Climate change has had a significant impact on weather pattern in recent decades. Such process can lead to global change and significant effect of the future of human existence. One of the consequences of such climate change that we can already observe is the scarcity of fresh water, which has a direct impact on human economic activity. Next. In Ukraine, the selenin of hydrothermal coefficient is used to classify and assess the aridity of territories. This is an integral indicator of the humoral region that takes into account heat the moisture. This indicator of moisture availability indicators favorable conditions of growing crops and is used assess moisture conditions only during the growing season. As you can see from the slide, the moisture index in Ukraine is decreasing and the aridity of regions is increasing along with the temperature. Next. One of the alternative source of fresh water is the Earth's atmosphere, because it contains water vapor and its amount is sufficient to meet all the needs of mankind. Water in the atmosphere can be contained in clouds, exist in the form of rock, and some water is present in the air in the form of water vapor. An important feature of the water contained in the Earth's atmosphere is its environmental safety, and therefore it is suitable for consumption and economic needs. Next. Existing systems of obtaining water from the atmosphere are still not widely used on the industrial scales. This can be explained by the fact that the technical characteristic of such installation don't simultaneously meet all the requirements for them at the same time. They include efficiency, cheapness, scalability, ability to operate in different regions, and stability. Next. The operation of the system for obtaining fresh water from the atmosphere can be divided into two stages. Capturing water vapor from the air and condensing this vapor to the liquid. Such system can use active or passive methods of extracting moisture from the atmosphere. The slide shows common installation for collective water from the air. Next. To prevent negative tendencies in agriculture, we offer a project of an autonomous air water harvesting plant that use the active condensing method. You can see the scheme of the installation on the screen. Next. To test our idea, we decide to create a working prototype of any autonomous installation of obtaining water from the air with automatic control, which is used on the basis of Arduino. The prototype can automatically turn the plant on and off under certain weather conditions, control the fullness of the tank with the produced water, and turn on water pump. The implementation of these elements of the plant's control system eliminated the human factor during the operation of the plant and increasing this efficiency. So an air turbine that draws air from the environment, humidity air is forced through the air ducts casing and enters the cooling system radiator. The heat is removed from the radiator by a cooling system pump through a turbine that use water as a coolant. And the container where the condensed water is collected is an ordinary plastic bottle with a water pump and water level sensor built in. The system is powered by a car battery. Next. The effective function of the system is ensured by the following electronic components selection by us: Arduino Uno R3, two humidity and temperature sensors, liquid lever sensor, two single-channel mechanical relay modules, step-down voltage converter, 12 power supply, and wires. Next. To set up automatic switch on off the until under favorable conditions, we use a formula that calculates the maximum mass of water that can be condensed. The analytic of the formula shows that the following condition must be met for our system to function. Next, this is done with the help of a control board that works in accordance with the program code we wrote. First, the program reads the values of the temperature and humidity sensors. Then, in accordance with the table, it converts the temperature value in the density of saturated air vapor and the density of saturated vapor of cool air. This is released using the array. A line of this code is shown below. Note that each element number of the array corresponds to a temperature value and element value of equal to the density of saturated water vapor. Next. Our prototype for producing water from air allowed us to experimentally test its performance and confirm the effectiveness using two automatic control unit based on Arduino. We always determined its efficiency. The result of the experiments are presented in the table. Next. The work is devoted to the prevention of an autonomous installation for obtaining water from the air to the prototype, which can serve to overcome the problem of the fresh water shortage in arid regions of the world and Ukraine during the growing season of agriculture plants. Next. The main result of the study you shows in slides. Thank you.
Thank you, Dar'ya. So, any questions?
Yeah, please.
I can start. Yes?
Okay. Так.
Yes, okay. Dar'ya, thank you for your beautiful work, and I have some questions. First of them is, what is your personal include into this work? What did you do personally?
Personally, I do prototype, write a code, and form concept of an autonomous installation.
Okay, thank you. And second question about prototype. What do you mean under the word prototype? Did you do this sample by yourself, or did you buy it, or what is it?
I buy this in internet.
You bought this? You bought, yes?
Yes. And in market теж bought.
And this part about automatization of the process, it's also not original. You used good known automatization procedure, yes?
Yes.
Yes. Okay. Okay, thank you.
Thank you for question.
I have also one question. Did you make this cost-benefit analysis of your project, or maybe compare the price for such analog equipment as you propose? In general, what is the price of your prototype?
Maybe $3,000 to $5,000 we cost.
And how much it was to buy this prototype in internet? As I understood, you buy something in internet to make this prototype equipment, yes? And what was the price for it? I think not so expensive, not 3,000 or 5,000 of euros.
Yes, we bought Arduino. That it cost 300 hryvnias. We bought a bottle of water and other we have in laboration in our school.
Okay, thank you, Dar'ya. Any question? Okay, so thank you, Dar'ya. And next,
Thank you.
Project, Жабровець Ольга. You can start. Yes.
Good afternoon, dear audience. My name is Žabrovec Ольga. I am 10th grade student in the Нововолинський Science Lyceum. I would like to present the result of my research work on the topic, the impact of military operation on the hydroecological state of the water bodies in Ukraine. Next slide, please. First of all, the purpose of the study was to analyze the impact of military operation on the hydroecological state of the water bodies in Ukraine, analyze potential military risks, and assess the prospects for recovery in the water sector. You can see the object and subject of the study, practical value, and research objectives in the slide. Next slide, please. Now the research topic. Today, each us knows from our own experience the terrible consequences of war. The entire ecosystem of the country is particularly catastrophic. Every day, the enemy state destroys the country's infrastructure and its troops and actively flanking the coastal areas, which has catastrophic consequences for the state of all water bodies in the country. The occupation forces are completely disregarding the rules of warfare and constantly destroying Ukraine's water potential. The destruction of the water sector infrastructure affects vast people and the entire ecosystem of our country. Of course, the military impact of the territory of Ukraine and environment began long before the full-scale invasion. The damage became noticeable even after Russian ideological annexion of Crimea. But the consequences are experiencing today began after February 24, 2022. They are extremely destructive for the whole country, and especially the water resources of our country, which became the object of our study. Next slide, please. Studying the research. Before studying any scientific research, it is necessary to familiarize yourself with the theoretical framework of the chosen topic. Therefore, we have studied scientific publication of the topic of the study material from the State Agency of Water Resources of Ukraine, data from Ukrainian and international media, and data from the Conflict and Environment Observatory. Next slide, please. The main stage of the study was the creation and interactive map that allows us to track the most affected water bodies of Ukraine since 2014, all occupied and occupied territories. The certain structure facilities that have a direct and indirect impact of the hydroecological state of certain water bodies are also made. You can personally view the information by scanning the QR code on the slide and assess the scale of this problem, which threatens all ecosystem. Next slide, please. We have also recreated the chronology of key incidents of the impact of military operation on the state of water infrastructure and water bodies in Ukraine. Of course, there were more such terrorist action of the part of Russia against the country water bodies, so the scale of this problem is very difficult to overestimate. Next slide, please. Since the beginning, the full-scale innovation water quality monitoring has been difficult, but thanks for professional specialists, samples have been taken from the most effective water bodies in the occupied territory. The graph shows the maximum recovered flows to biogenic and organic water quality indication by basin, sub-basin as of November 2022. In the river basis, water contain heavy metals, cadmium, lead, mercury, copper, zinc, oil product, and integrated content of pesticides, polyaromatic hydrocarbons, and volatile organic compounds. The reason for the prevention of damage pollutory wickets and equipment of the river and their volleys, which emit their thermal pollutions. Next slide, please. After that, we presented potential risks for Ukrainians' water bodies against the backdrop of Russian aggression. For example, in the event of disaster at the Kakhovska hydropower plants, Kherson region, 18 cities will be completely flooded and 25 will be particularly flooded. Flooded of 5 cities, Dnipro, Kamensk, Marhanets, Nikopol, Moskovsk, and more than 40 settlements may occur, or the dam of Kamensk reserve is destroyed. In the Kaniv hydropower plants is Poltava region is possible the Kremenchuk hydro power plants is destroyed. However, the most dangerous of the possible options is the shutdown of the Zaporizhzhia nuclear power plants. A Russian terrorist attack could leave the Zaporizhzhia nuclear power plants without water cooling. Water for the Zaporizhzhia nuclear power plants is taken from the Kakhovska reserve. The destruction of the Kakhovska dam would also make it impossible to supply water to Crimea for the coming year. Overall, the consequences of such a terrorist attack could be a historic catastrophe. These forecasts make it clear the environmental impact of the conflict are emergent, that even when the fighting stops, the violence will be left for a long time to come. Next slide, please. In turn, we have proposed that message to improve the hydroecological state of Ukraine in the post-war period. You can see them on the slide, namely the restoration of critical infrastructure in the water sector, attracting investors, systematic biochemical analysis of water cleaning up military waste with the help of volunteers, the attracting reparation of the water sector. Next slide, please. And at the end, the research, the main conclusions were made, which you can also see on this slide. However, the work will definitely not end here. I will continue to explore this issue in order to draw the attention of the whole world to this problem and change it for the better. Thank you for attention.
Thank you, Olga. Please, questions.
Can I start?
Yes.
Olga, thank you for your report. And tell me, please, I would like to discuss about pre-last slide, where are the proposition of for the citation. Can you show? Yes. On my mind, it's necessary to put the first point, stop the war. Because all these propositions are not useful and fruitful without this first and more main condition. Do you agree with me?
Sorry, I don't. Can you repeat your question?
It's not question, it's proposition. To put this on this slide, the first point, stop the war. I agree with me.
Okay,
Because
thank you.
All this activity, it's okay, it's good, but it's not effective without this proposition.
Okay, thank you for proposition. In the future, we can.
By big letters.
Yeah.
But I have questions, really questions. Again, this slide with information about the content of the water. Yes, this one. My proposal, also not question, because I did this question before, the proposition to show the level of requirements to water. On this left picture, you can show the level of requirements. Do you understand? Yes?
Yes.
By line. It first and second one, the requirements to the water is usually for nitrate ions. We calculate in concentration of nitrate, not N, not only element of nitrogen. Do you understand? Yes.
Yes, of course.
The concentration of nitrogen, and more. On my mind, it's right to show the concentration of nitrate ions. And in this case, maybe you're right, and we will have the bigger figures of concentration than requirements.
Yes, of course. Thank you. Your proposition is very important to my future work.
And these organic indicators, it's very good, but I'm not sure. Also, it's necessary to show the level of requirements. Maybe it will be more effective. In any case, your report is very good and very effective. But if somebody from really specialist from Sweden, in any case, you can tell that in our country another requirements to different compounds than in Europe or in peace or in Sweden, for example. It's really different. In our country, less, more strong requirements. But it's possible to. Okay, if you will win the first place, we're ready to help you and to work with you for preparing of this report. Okay?
Yeah.
You can tell thank you.
Thank you.
Not at all.
One more question from Andrei Viktorovich. Андрій Вікторович.
От робота проведена, є певні, мабуть, рекомендації нароблені. Так, а якщо воїни або стихійні лиха, або техногенні катастрофи, які можете загальні рекомендації дати, от, щоб організувати в разі такої події в іншій країні, наприклад, такі типові рекомендації щойно налагодження моніторингу якості води? І які висновки треба отримати з цього моніторингу?
We have not started this issue yet, but we will definitely plan attention to the next step of our work. Thank you for nothing it.
Оля, I have a question. Are you going to continue with this?
Sorry, I don't hear you.
Are you going to continue with this project in future? Or
Yes, of course. I have a very big plan about this project.
Okay, are you going to make monitoring only surface water, or maybe you can look for something bad, in this case, in drinking water, for example?
Maybe, but it's a future problem and I want to learn it.
Okay, how many people use this water from surface water in this region you investigate? Do you know?
I don't have this information at the moment because in the deoccupied territory have a very big people and I don't have, and our country don't have this static information.
Okay, thank you. Any questions to Ola? Okay, thank you, Olga. Next project, Kozak Anastасія, Kosogін Артур. Are you ready?
Yes.
Okay.
I don't see presentation.
Just wait for a moment.
Okay.
Okay, you can start.
Okay. Good morning, dear members of the jury. I'm Anastasia Kozak and Artur Kosogin are students of the 10th grade of Lyceum number 142 in Kyiv. Topic of our work is device for resorption water purification in emergency situations. Next, please. Providing people with quality potable water is one of the main tasks of today. The stage of water disinfection is mandatory considering the quality of the water that comes to us from the water tap. An insufficient amount of disinfecting agents is the development of pathogenic organisms in water, and disinfection by treating water with active chlorine is the formation of new dangerous compounds. Next, please. Therefore, the purpose of the work is development of a device for water purification based on activated carbon and verification of its effectiveness for removing water color and residual active chlorine. To achieve the set goal, it was necessary to solve the following tasks. The first one, analysis methods of water disinfection. The second, analysis of water of the city water supply network for the content of main components and active chlorine. The third, propose a method of water purification. And the last, develop a device for water purification in emergency situations. Next, please. Currently, chlorination is the most common method of water disinfection. The consequences of excessive content of disinfecting agents in water is the formation of so-called chlorination byproducts, which are toxic and carcinogenic to humans. Determination of residual chlorine content in water samples was carried out by an express method based on odometry. Water analysis for residual chlorine content was carried out in 2021 and 2022. The results are shown in the figures. In 2021, a high content of residual chlorine was observed in the water supply network of the city of Kyiv. The average value of 0.7 milligram per cubic decimeter, which exceeds the permissible norms, and this is from 0.3 to 0.5 milligram per cubic decimeter.
Therefore, the presence of active chlorine in combination with organic substances in potable water can lead to the formation of organochlorine, which is dangerous for humans. So such water needs local purification, for example, by sorption methods based on activated carbon. Next, please.
For this, we decided to use a carbon filter. To make it, we mixed two components, activated carbon 86% and polyethylene 14% as a binder. After that, we stir the mixture and pour it into a mold, then heat it for 2 hours at a temperature of 190 degrees Celsius, then cool it and remove the produced carbon filter. Next, please. The effectiveness of the use of the created carbon filters was checked on tap water by determining the change in its color and the content of active chlorine on the device we developed, which consists of the following elements: container with chlorinated water, nozzle of the device for water purification in which a carbon filter is fixated, and a faucet for adjusting the flow rate and sampling purified water. To conduct the experiment, we took 6 liters of tap water, determined the color in it, which was 42 degrees, chlorinated it, and set the content of active chlorine in it at the level of 1 milligram per liter. This water was filtrated at a water flow rate of 50 cubic centimeters per minute. A sample was taken for analysis in each liter of filtrated water to determine the residual color and the content of residual active chlorine. The results of the analysis showed that with each liter of water passed through the carbon filter, the efficiency of purification drops from 42 to 32%, which corresponds to the residual color of the water of 24 to 28 degrees, respectively. The obtained values do not correspond to the norms of Sanping 2010, but they correspond to the norms established during martial law. Therefore, water purified on a carbon filter is suitable for drinking. Next, please.
So, conclusions. An analysis of water disinfection methods was carried out. It has been established that chlorination is one of the most effective methods of removing pathogenic microorganisms from water. It was found that to reduce the content of residual chlorine in water and its color, one of the most effective methods of local water purification is sorption methods using activated carbon.
A device was developed for water purification in emergency situations using a pill-type carbon filter to reduce water color and remove residual active chlorine. Safe water was obtained, which corresponds to the norms in force during the martial law.
The practical significance of the work is compactness and versatility of the use of the device for water from various sources.
Obtaining microbiologically safe water in various conditions, and ease of manufacture and high efficiency of the pill-type carbon filter. Next, please. Thank you for your attention.
You guys, so who will start with questions?
I will start as usual. Okay. My question is the following. You really did interesting proposition for special conditions for war condition and so on and so on. But why you cannot use this filter which are selling in all shops with cartridges with activated carbon? What is the difference between your proposition and typical proposition?
The difference is that we have a filter that has a static shape, so the activated carbon stays in place and always filtrates the water, while in those that the markets are selling, they have they can be actually moved by the water, and because they use
in our filter we have we created a clear structure because we use polymers, and for this reason when the water moves through the entire volume of the filter, we have a better effectiveness, because in another filters which are you can buy in different shops, they in those filters water channels are formed along which water moves, and for this reason it's hasn't some good effectiveness.
Because they use actually resin, so the particles of the activated carbon are movable. they are not static. So the water can just move them and pass through without getting filtrated.
On my mind, you forgot about very main difference. Your filter is can filter non-soluble particles, and the typical filter cannot do it.
That's also the upside of our filter.
It's more important. And another one is on my mind. If you will take the Peter with cartridge, it's big, not big, but not small thing, and you cannot put it to bag and go to the war, for example. And in your case, your filter is very small and very compact. And this also your one from the very important difference between your and typical production filter.
Could I add? Could I add? Because, and also I want to add that our our filter performs two roles. It's sorption because we use activated carbon, and also filtering because there is no need to separate the particles from the water because they are securely fixed in the filter.
Okay.
Okay, thank you. It's enough.
I see question from Андрій Вікторович. Please.
Ви не пробували удосконалити свою технологію і застосувати тверді препарати хлору? Чи ви про них взагалі не чули?
Про що, Андрій Вікторович?
Тверді препарати хлору, хлору таблетка.
Actually, we used the floor pills, so they actually it works because we use those solid pills, and basically they chlorinate the water as the gas does the same way, so it also works. Our filter filtrates both soluble and unsoluble pollutioners.
Це ж незручно, а таблетований це робить технологію універсальною з точки зору логістики. Навіть.
We used also pills.
Yes.
Okay, question from Rostislav, please.
Can you please explain a little bit what would be what is the capacity in liters of the carbon tablet that you have designed?
The capacity is 6 liters because you can still use it after 6 liters, but after that the filtration drops a lot. So actually 6 liters, that's not a great amount for big machines, but for such a small portable filter, it is a very big amount because there are something of Chinese creations that can filter only about a liter. Now we can filter 6.
And what is your opinion on the application? So the capacity is, well, it is higher into the Chinese samples you compare, but it's still not very high. So what is your opinion on the possible applications of such tablets?
We would like to add a bit more carbon to make it about 88%, because we know that a high amount of carbon, if we add a high amount of carbon, the polyethylene won't just hold it. So we want to add as much carbon as we can, and we wanted to change the form of the tablet to make it smaller in the radius, but to make it longer. So the more water water could pass through it the longer way and get more filtrated, and so this filter will have more volume, and it would be able to filtrate more water.
Okay, and what is your target on the volume? So how many liters you would like your tablet to treat? What do you think? You can...
We thought about to increase it to something about 10 liters, so it would take we could filtrate to two big bottles of water, or something like that.
Thank you.
Okay, thank you, Artur. Thank you, Anastasia. If we have no question, so we can continue with Кондратенко Поліна.
Мене чути?
Yes.
Okay. Can I start?
Yes, you can.
Good morning, everyone. I am Polina Kondratenko, a 9th grade student of the Central Ukrainian Scientific Body in Lyceum, and I would like to present my research paper, The Use of Solar Energy for Seawater Desalination as a Way to Preserve the Planet's Resource Supply. Next slide, please. The main goal of our research is to analyze water desalination methods and create equipment to improve water desalination using renewable energy sources. You can find a more detailed scientific apparatus of the research on the screen. Next slide, please. While analyzing the topic, it was found out that the issue of seawater desalination plants is not widespread and popular enough. Indeed, the planet's freshwater reserves are being depleted continuously and quickly with irreparable consequences. Today, the problem of freshwater shortage affects both poor and rich countries, so the development of desalination farms is quite promising. I would like to offer an alternative solution to this problem, a project to develop a seawater desalination farm. Next slide, please. The farm itself has the shape of the hemisphere. The surface of this hemisphere is transparent and consists of two layers and a layer of air between them. Floating solar panels are located near the farm. They provide the installation with energy and are connected to it by wires. Next slide, please. In the middle of the hemisphere, there is an air duct that is arranged spirally starting from the highest point of the sphere and spirally descends down the wall, creating a certain angle for water to drain off on its own. There are also plates on which water droplets fall after condensation. They are placed as sides around the perimeter of the entire structure and inclined at an angle. The farm is equipped with automated gateways. The infrastructure is located on a dark-colored platform equipped with weights. Next slide, please. The principle of its operation is as follows. The seawater in the farm, having received a certain amount of energy, begins an active evaporation process. When the water vaporizes, an air humidity sensor triggered and an electric air pump powered by solar panels is switched on. The air pump pushes the humid air into the duct. The air touches the walls of the duct, which have a lower temperature. The drops condense. The condensed water will drain out through the spiral structure of the duct due to the gravity and air movement. At the end of the duct, the air comes out with reduced humidity and temperature. At the same time, water flows out of the pipe and hits the plates, and from there, due to the inclination of the sides and the tube, it flows into the tank where the desalination water is already located. The seawater from which the fresh water evaporates enters the structure through the gateways that are programmed to open under certain conditions, such as the right time and the absence of waves. When this gateways open, the solution remaining at the bottom of the farm flows into the sea, and new water from the sea enters the structure. Next slide, please. We compared our frame with other similar ideas. The advantage of our system is that it's easy to transport, install, and use. It has a fairly high capacity, and it doesn't depend on time, day, or year. Next slide, please. During the study, the illumination of the territory was measured. Next slide, please. Based on data obtained during the elimination measurements, the amount of energy lost and the amount of energy supplied to the installation was calculated. The length and number of turns of the air duct were determined, as well as the amount of condensed water per second. The formulas for some of the calculation are shown on the screen. Next slide, please. It was decided to design a model of the farm. Work has begun on writing a program code for the operation of the electromechanical parts that will ensure the farm's automation. The Arduino Studio board and MIXE software were used for programming. Next slide, please. Next, we start developing the layout. Next slide. The study has led to following conclusions. The planet's freshwater reserves are being depleted continuously and rapidly with irreparable consequences. We create a theoretical model of the farm. By analyzing similar devices, we compared their pluses and minuses in comparison with other farms. The calculations were made to prove that the farm is quite efficient. A practical model was designed and made. Thank you for your attention. I'm right to your questions.
Thank you, Поліна. So who will start with questions? Maybe I will ask my first question about, did you calculate the price for your?
No, now we didn't calculate the price, but in the future, it's in our plans.
Окей. Бачу, Андрій Романович.
Вибачте, на українській мові буду казати. У вас там в висновках можливість фільтрування води. А в роботах ви вели розрахунки на конденсацію і випаровування. Дивіться, 5 можливість фільтрування води. А от слайд 9, там з цим не пов'язано. Який зв'язок з цим?
It's don't correct in the our project because we desalination water, no filtrate.
Це, напевно, все-таки да. Пристрій, чи якось так сказати. Продуктивність по воді.
I can't hear you.
Дякую. Добре, дякую.
Okay, one more questions. Who can ask something more? Okay, what is your next step in your project? What are you going to do? And when?
I'd like to create a working model of the farm taking into account a great number of both macro and microscopic parameters.
Okay, so if you have no question to Polina, thank you, Polina. And the last one is Lobuneць Дар'я with project.
Yes, I'm here.
Okay.
So, good afternoon.
So you can start, please.
Okay, so hello everyone. My name is Dar'ya Lobunець and I'm student of 11th grade in Шостка Specialized School number 1. I'm presenting a research project, development of technology for the production of eco-packaging from seagrass. I've been working with my teachers Mechik Marina Yurievna and Pavlenko Oksana Vyacheslavina. The work was made on the territory of Shisumdo. Next slide. The issue of the work is decreasing forest plantations. Every day more and more forests are being cut down. Another important reason is the pollution of the world's bays and beaches with the rise of seagrass throwing up on land. At the moment, this situation is happening in Florida, in the United States. There is a throwing out of sargassum brown algae. People are anxious, both citizens and tourists. The main problem of the pulp and paper industry in Ukraine is the lack of raw materials, which can be replaced by alternative material and production methods. Next slide, please. The goal of the research is
to study the structure of the seagrass Zostera marina, to study the specifics of recycling non-wood alternative raw material into paper products, to develop a technology for the production of paper products, making an experimental sample of eco-paper, studying the characteristics of the produced paper as eco-packaging. Next slide, please. The main raw material for paper is cellulose, a material whose mechanical strength combined with its elasticity makes it ideal for making paper. That's why it is used to make a variety of packaging paper, cardboards, and ordinary paper used for notebooks and textbooks. Chemical composition of this algae is 45% of protein, 35% of carbohydrates, 10% of lipids. It also contains iodine, iron, zinc, copper, and cobalt. In fact, it contains a large amount of vitamins and biologically active elements. Next slide, please. It's a type of sea plant that grows in coastal areas along the seashore. It's often found in bays, lagoons, and beaches. It also grows on the territory of Ukrainian seas, in particular in the Black Sea and Sea of Azov. The Zostera I used was collected in the Karkinets Bay. Classification is green plants. Family Camelliaceae. Species Zostera and type Zostera marina. Next slide, please. Agriculture use of Zostera marina. On this slide, you can see that Zostera marina is used for bedding mattresses and furnitures, as a packaging material, as well as fertilizer, warming material, pet bedding, and for the manufacture of building materials, also in purpose of its medical properties as a flavoring for dishes, and even its vitamins. Here in this slide, you can see vitamins that you can also buy in pharmacy. Next slide, please. Production technology. Dry the grass in an oven until it becomes fragile and then crush it. To bleach the material, we tried such reagent as sodium hypochlorite, bleach, and hydrogen peroxide. Hydrogen peroxide was chosen as a bleaching ingredient to create a waste-free, environmentally friendly technology. Then, the crushed grass is dipped in a hydrogen peroxide solution to brighten it. The bleached mass is washed with water and bleached to a smooth state. Next slide, please. I experimented with starch, gelatin, and alginate, but the paper samples didn't follow the regulatory requirement. So I decided to add 3% starch solution and 1% gelatin solution on the mesh. I just added them both. Separate the wet samples and iron them. Form the samples and glue them with the starch solution. I found out that eco paper is elastic, tight, but fragile, and it doesn't burn but fades. Next slide, please. Based on the results of the experiment, it can be stated that the use of seagrass resources is possible and economically rational. The obtained samples of paper products satisfy the requirements for packaging paper products in terms of weight, thickness, and so on. However, for food packaging, the paper must comply with the requirements of the current regulatory documents. Next slide, please. Conclusions. We have analyzed the structure of the Zostera marina. We considered the features of seagrass processing into paper products, developed a technology for producing eco-paper from seagrass. We made an experimental sample of eco-paper. We tested the characteristics of the produced eco-paper. Based on the results of the work, the possibility of using Zostera marina grass as an alternative raw material for the pulp and paper industry was justified. The analysis of the obtained paper samples indicates the potential of developing the direction in order to reduce the harvest of forest resources for paper production. Given the environmental benefits of this method, it can be offered for future improvements and adoption in production with other types of algae. The resulting paper materials can be used in the manufacture of eco-packaging, single-use dishes, and so on. Also, I really want to experiment with other types of Zostera, not only Zostera of algae. As I said earlier, there exists sargassum, brown algae that can be used too, I guess, but I didn't make research yet, so it's really justified, and I think it will be economically used. Thank you for attention.
Thank you, Dar'ya. So let's start with questions. Who will be the first? I see Oksana, please. Oksana?
Ну, давайте я для початку.
Do you investigate how many green grass is in Ukraine and how many papers you can produce from this and about all over the world also?
I haven't investigated how many this Zostera is in Ukraine because it's increasing each year, like it's normally for plants. So I didn't make research on it. But for example, I used 3 kilograms of Zostera marina and I had a lot of samples, but they were experimentally samples. So I used only normal ones that were okay to present. So I had only 4. From all 3 kilograms, but it was succeeded samples. And I think we should make research of Zostera marina, how much is it in Ukraine? Yeah.
Maybe this is not so much seagrass, and maybe it's not the reason to make a paper from so small account.
Well, in Karkinets Bay, there are a lot of seagrass and people just collecting it. And after you can buy it in the internet, like just order. And it's really cheap production and it's increasing. So I think it will be economically used. And like cleaning beaches, cleaning lagoons, it's really good.
Thank you.
Thank you, Дар'я. Тетяна Євгенівна.
I also plan to ask about the economical properties of this work. And did you compare? I understand that this is more better than do the paper from trees, but it's not enough on my end. And it would be very good to show some figures about the economical points of this proposition. Can you tell something? Did you compare really with the traditional method?
Well, I compared technology. Yes, I took technology, but which is more economically, I guess it's Algae, because it's more cheap than wooden material. And yeah, wooden material is need to be saved because like every year it's more and more cut it down. So I should put some researches. I think in my work I wrote comparison. I wrote some tablets about this, but I cannot really remember.
Thank you.
Yes, thank you. And Roman Vasilyevich, I saw a question.
Have you compared the characteristics of your paper with similar packaging paper?
Yes, I did. So I can say that it's similar to packaging paper because I made experiment with these characteristics. As I wrote, my paper has elasticity and it's little fragile because I need to add more starch. It's not enough glue, and I will experiment with this, how I can improve my paper, because now it's really ecological. You can even eat it because there are not a lot of toxins and so on, because I bleached it, I delignificated, so it has no something bad for human body, for human health. So yeah, you can use it and you can eat it.
Maybe you have to place this results for your presentation, because I don't see these results in your presentation.
Comparison with normal paper. Okay,
Yes.
Thank you. Thank you for advice.
Thank you.
Ask one more question. Did you try to eat your paper?
Yes, I tried to eat it. It has no taste, like normal paper, I can say. Like if you eat normal paper from wood material, like it's not really nice, but still you can eat it. And this, because of Zostera marina has healthy properties,
yeah, you can eat it. So, like people use the Stera marina for vitamins, so why not?
It's very interesting proposition. But you can be very careful with it because it's necessary to make a lot of different investigations in order to obtain the recommendation of our healthy service for this material as food material. Okay,
Yes,
thank
yes, I guess, yeah.
Mm-hmm. Any questions? I have one question. Is it new technology or we have something the same in the world?
We have a lot of technologies for making paper. For example, in China, they made research how to make paper from red algae, something like this. They have it, but from green Zostera marina, no one researched it. So it has little special technology of making. And for example, KPI, University in Kyiv, it made paper from sunflowers, of base of sunflowers. And after boy made, like one boy in Ukraine, he made the paper from just leaves, leaves that people always burn. And so he made this research, and now he's famous. And his work is really popular, and like it's eco-friendly paper. So it has a lot of technologies, but no one touched Zostera marina. So I tried to do it.
I have one more question. Is this Zostera marina popular abroad, or this is original?
No, it's not. It's not original. Like it has Zostera marina in Ukraine, around the world too. A lot of places where it's surrounded. So I think we can save beaches of around the world, not only our Karkinit Bay or something.
Okay, thank you, Дар'я.
Thank you.
All participants. Дякую всім, дякую керівникам, хто присутній. Отже, зараз журі залишається на обговорення ваших захистів. У нас, в принципі, достатньо часу. Ми там планували на 13-те оголошення. Я думаю, що ми можемо зробити це о 12:30. Учасники, суперфіналісти і керівники зможуть перепідключитися.
Я думаю, що ми можемо це зробити о 12.
О 12-й? Ну, давайте навіть о 12-й. До 12-й члени журі залишаються, а суперфіналісти або в зал очікування, або перепідключитись на 12-ту тоді. Добре? Так. Отже, колеги, за хвилинку розпочнемо наше оголошення результатів. Ну, я так дивлюсь, що майже всі тут, всі присутні. Так, дуже вам дякую за плідну працю протягом цих 2 днів. І учасникам, які турбувалися і хвилювалися, і членам журі, які приймали такі обґрунтовані рішення щодо того, хто пройде в суперфінал і як розподіляться місця в суперфіналі. Я би насправді хотіла надати слово голові журі Андрусішиній Ірині Миколаївні для того, щоб вона, так би мовити...
Дякую, Юля. Я вітаю всіх сьогоднішніх учасників такого поважного заходу, важливого для нашої країни. Я вітаю всіх сьогоднішніх переможців. Як науковець знаю, наскільки це було складно, наскільки складно робити науку в нашій країні під час війни загалом. Тому я шаную вашу велику працю всіх учасників конференції. І я хочу побажати, хто буде переможцем, хто займе інше місце, але хочу побажати вам всім не втрачати надії, йти шляхом науковим вперед, мріяти, здійснювати свої мрії і в подальших в своїх наукових кроках бажаю дуже великих успіхів. І хочу всім учасникам, молодим учасникам подякувати за участь, за достойні презентації. Вони дійсно були достойні. І передаю Юлі слово для того, щоб вона оголосила результати сьогоднішнього конкурсу.
Колеги, отже, наші результати. Так. Це наші суперфіналісти, яких ми сьогодні мали честь заслухати. Видно екран, колеги? Так, я сподіваюся, що видно. Журі оцінювала за тими критеріями, які всім вам відомі. Оцінювала рівень поданої роботи того проєкту, який був написаний. Оцінювала рівень технічного чи методології дослідження, наскільки ви вправно з цим впоралися. Окремим сьогодні критерієм був також володіння англійською мовою і ваші, так би мовити, здібності презентатора, оратора, оцінювали ваші відповіді на питання і також практичний аспект застосування ваших пропозицій, в ваших проєктах на практиці і в Україні, і в світі. Тому за результатами роботи по оцінюванню ваших проєктів маємо наступні результати. Отже, третє місце в нас посіли 3 роботи. Бондаренко Владислав, Виговська Дар'я, Кондратенко Поліна. Вітаю. І, відповідно, третє місце у нас отримує премію по 2000 гривень на ваші подальші, так би мовити, розробки. Так. Переходимо до другого місця. Друге місце в нас посіли 2 роботи. Жабровець Ольга і Лобунець Дар'я з відповідними преміями по 3000 гривень. Окрема премія від спонсора конкурсу компанії «Кософт» присуджується Жабровець Ользі за її таку дуже серйозну і дуже вагому роботу з приводу стану гідроекологічного стану водних об'єктів України. Тематика на часі, і вона, на жаль, буде актуальною ще і в подальшому, тому було прийнято рішення, що додатково премується Жабровець Ольга додатковою премією від спонсора конкурсу компанії «Кософт». Тому вітаємо і Ольгу, і Дар'ю з отриманими місцями. І перше місце, відповідно, посідає Козак Анастасія і Косогін Артур, які будуть представляти свій проєкт на міжнародному фіналі в Стокгольмі, отримують премію 5000 гривень і, відповідно, готуються до міжнародного фіналу і допрацьовують свою роботу відповідно до тих рекомендацій, які надали члени журі під час захисту, і потім ми все це ще пропрацюємо, тому вітаю наших переможців. Це наші гран-при. Окремо подяка всім керівникам суперфіналістів. Премія по 1000 гривень вручається кожному керівнику, і окремо наша за те, що ви займаєтесь цими актуальними питаннями, допомагаєте дітям. І сподіваюся, що ми з вами не прощаємося і зустрінемося наступного року з вашими новими проєктами, з вашими новими дослідженнями і новими дітками. Тому всім дякую. Я би хотіла ще надати слово Оксані Денис, координатору нашого конкурсу. Будь ласка, пані Оксана.
Ну, я приєднуюся до всіх привітань учасникам конкурсу. Ваші всі роботи дуже чудові, актуальні, і ви всі чудові. І керівники, і учні. Окремо я хотіла би висловити подяку не тільки від себе, я думаю, але й від всіх учасників конкурсу, не тільки від фіналістів, громадській організації «Вотернет» і особливо Юлії Бережній, яка провела надзвичайно велику роботу. Я знаю, скільки це часу коштує. І незважаючи на ці всі складні умови, військовий стан і велику загруженість громадської організації «Вотернет» іншими справами, також вкрай важливими і актуальними, незважаючи на це, вони знайшли час, щоб провести цей конкурс і провести, я вам скажу, на дуже високому рівні, тому що я знаю насправді, скільки часу і скільки сил це коштує. Окрема подяка Тетяні Євгенівні Мітченко, яка від початку конкурсу, можна сказати, з 2004 року нам допомагає, цей конкурс підтримує, перейняла його і все робить для того, щоб він відбувся навіть під час війни. Ну і, звичайно, компанія «Екософт», яка так само, будучи в Ірпіні, перебуваючи і під обстрілами, і зараз перебуваючи в важких фінансовій ситуації, в важких умовах, все одно знайшла кошти і знайшла можливість підтримати наш конкурс і підтримати керівників і учасників конкурсу. Велике вам всім спасибі. Ну і, звичайно, членам журі, які не пошкодували свого часу, незважаючи на зайнятість на основній роботі, знайшли можливість взяти участь в нашому конкурсі, оцінювати роботи, ну і своїми запитаннями допомагати учасникам як найкраще висвітлювати свої роботи. Дуже дякую вам всім.
Дякуємо, пані Оксано. Вам також відповідно за те, що ви наш такий натхненний янгол нашого конкурсу. І, колеги, друзі, ще раз всім дякую. Дякую також нашому спонсору, бо дійсно без фінансової підтримки дуже складно якось зараз і все це і проводити, і тим паче нагороджувати преміями всіх достойних, всіх учасників і керівників, тому ще раз дякую. Організаційні моменти. Ваші дипломи будуть надіслані, як я вже писала, протягом 2 тижнів. Щодо преміювання, вам окремо буде також надісланий лист, яким чином то все буде відбуватися. Тому будемо з вами на зв'язку. Якщо якісь організаційні питання, ви можете мене набрати або написати. І, я так розумію, що не прощаємося. Дуже сильні проекти. Хотілося, щоб наступного року ми також з вами зустрілися з вашими новими ідеями і, так би мовити, вже продовжили працювати над вирішенням водних проблем нашої країни. Тому ще раз всім дякую. Члени журі, велика вам повага за ваш час і вдячність за те, що дійсно ви як волонтери, знаєте, на такому фронті освітньому, науковому, тому це також дуже вагомо. Всім вдячна, всім бажаю мирного, тихого дня, наскільки це можливо. Тримаємося, все буде Україна. Слава Україні!
Героям слава!
До побачення!
До побачення!
Дякую.